Today we're going to keep on with the normal discussion. We should have done a lot of what I would call straightforward normal problems in class and in in class. Just ones where I would give you a normal setup and say what percentage of the observations are between here and here. You should be pretty good at that by now. Here's what I would consider to be a backwards normal problem. Um, in a backwards normal problem, you're going to be given the percentage, and you're going to have to find the raw score, the actual number. And that's going to go with these three steps. We're going to sketch the area we're looking for. We're going to use the table backwards, which I'll show you how to do. And then we're going to use the same z-score formula, but use it the other way. Okay, so in this scenario, you need to be in the best 15% at the putt-putt qualifying tournament. And in this case, best is lowest. And anytime we're doing a race or playing golf, we want to be the low numbers. Okay, so the area you need to be in this distribution is normal with mean 31 and standard deviation 2.5. You need to be down here in the bottom 15%. So what we're looking for is what score you need to end up there. So here's my sketch. That's the only sketch you really need to have. Next, I want to use the table that we've been using one way. I'm going to use it the other way. And luckily, here's a table. So what you need to do is find as close as you can get to 15% in this table, in the middle of the table. All right, and I've highlighted 0.1492. That's the closest we can get to 15%. And for right now, we'll get a more accurate way to do this later, but for right now, just get the closest one. So the top of the table is cut off, but this is what those columns would read. Which means that we have the percentage and we're looking for the z-score. So the z-score is negative 1.04 that corresponds as closely as we can to 15%. So my z-score is negative 1.04. That's step 2. And now to get the raw score, the actual putt-putt score, we just need to change that back with the formula that we've been using. You can rearrange this formula and solve it for x, or you can just plug in what you know and do the algebra on it, and it's going to work. So my z is negative 1.04. My x is what I'm looking for, the actual score, minus 31, that's my average, over 2.5, that's my standard deviation. And let's calculate that. Exit out of here. That was, I need to do negative 1.04. I need to multiply that by 2.5. And I need to add 31. And our answer is 28.4. All right, so if it's a real world situation, you need a whole number. Maybe it's 28, maybe it's 29. It's just an example, so we're not going to worry about the details. So that's what I would call a normal backwards. All right. Normally, I give you a raw score, you change it to a z, you sketch it, you look it up on the chart. Now we do that in reverse to go from z-score to raw score. So there we go, that's backwards. Next, the other topic we need to get into too while we wrap up this chapter, it's called assessing normality. Basically, I'm going to give you a set of data, and you're going to tell me, is it normal? Could it be taken from a normal population? So I'm going to use this set of data. We're going to stick with the golf theme. We had putt-putt, now we have golf. This is the 2013 Masters, perhaps the biggest golf tournament in the world. And these are the scores from that tournament. All right, so I took all of these scores, the 279, 279, 281. I can't seem to scroll it down, so I'll just show you. I typed all those in my calculator into my list. Okay, and there are 61 values in that list, all the way up to 304. So what we're trying to do is see, do these numbers appear to be normal? And there's evidence for that or against that. So let's see. You need to write down for sure these A, B, C, and D under assessing normality. So the first thing you can do is see if your graph is symmetrical. You can make a histogram and see, you know, it could be a stem and leaf or a dot plot, but a histogram is usually one we'll use, and it's made in your calculator. And you can see, you know, does this rule it out from being normal? Does it support it being normal? Let's see. So in my graph, stat plot number 1 is turned on. Zoom 9, remember, will get you where you need to be. So according to this picture, I wouldn't say that it's ruled out from being normal. It's kind of oddly shaped. Got a kind of a, I would say, if anything, a little skew right. One thing I would hesitate here, and if this is your test and you are answering this question, you would want to show evidence by sketching this graph. And we can put that over here in our notes. So does this rule it out? I wouldn't say this rules it out. You know, there's somewhat symmetry. At least the peak is in the middle, and it's kind of a guessing game at this point. You know, we haven't declared it not normal. It's not strongly skewed, but this thing doesn't exactly look like a normal graph. One hesitation here. This is the graph that the calculator set up on its own. Remember, if you change the X scale on your window, maybe I make it 3, and then the graph looks, I would say, a little bit more normal. You can change your X scale to 2. You know, you could play around with the numbers, and that looks, the smaller our scale, the more normal it looks to me. You could change it to 5, go the other way, and you have fewer bars, and none of them really eliminate it from being normal, but just don't treat the histogram that the calculator spits out as the gold standard, because different histograms can have some different shapes. So anyway, there's one way. We're going to look at a graph and check for symmetry. Number 2, if it's in fact normal, the mean and median should be the same. That's one aspect of a normal graph. Because of the symmetry, the mean and median should be relatively the same. So remember, to get info about your list, go to Stat, go to Calc, one variable stats, and hit Enter. And here's those. The average is 290.377. The median is 290. So that's very close. 290 and 290.4, we'll call it. The mean was 290.4. The median was 290. So that, I'm thinking, is good. That's evidence for normal. Smiley face there. This one didn't really show normal, but it didn't rule it out. So I'm giving that a straight face, because it's still pretty decent evidence for normal. All right, now this one takes a little bit of time. Check the 68, 95, 99.7 rule. So let's talk about that one. If it's normal, 68% of the data should be within 1 standard deviation of the mean. So let's look at our data again. X bar and S are our sample mean and standard deviation. So we had 290.4 and let's call that 5.1. 290.4 and 5.1. So 68% of my numbers should be between, let's see, 290.4 minus 5.1 would be 285.3. And if I add the 5.1, I'm at 295.5. All right, if I go again and add and subtract another 5.1, that's going to take me down to 280.2 and up to 300.6, 305.7, and 275.1. So, according to the rule, 68% of my data should be between 285.3 and 295.5. Now, this is going to be a rough calculation because I've got decimal cutoffs and I've got whole number scores, but again, we're just checking. So I'm going to include anything from 286 to 295 in the top group. 286 to 295. So back on my list, 286, the 11th, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 37, 38, 39, 40, 41, 42, 43, 43. So 43 of my 61 numbers made it into that group. And to check our percentage, 43 out of 61 is 70%. All right, nearest whole percent is 70, so it's pretty good. All right, and I didn't get this as normal data. I just assumed that the golf scores might be. So that's pretty close. We got 68. We're looking for 68. We got 70. Now, for the sake of time in this video, I'm not going to go through and count again, but I'm assuming that those other two are pretty close. I'll leave this data in my calculator, and I'll figure it out a little later, and I'll share that with you in class. So checking the 68, 95, 99.7 are the empirical rules. So far, through one check, we're in pretty good shape. Okay, so I don't want to do that because I need to show you this new graph. Normal probability plot. We have dealt with several of the graphs in your calculator. Stat plot. Go into plot 1. We have the scatter plot, we have the line graph, the histogram, the box plot, the modified box plot. And then that one right there, it's called a normal probability plot. So let's set it to that one. My data's in list 1. I think my marks are all good. Zoom 9. Okay, so normal probability plot. What does this tell us? This tells us what happens in the calculation of this graph is it sort of denormalizes the data and straightens it out. So if your data is normal, this should result in a fairly straight line for normal probability plot. And this I would consider a fairly straight line. All right, normal data, straight line. And that's our fourth and final way. So I would say overall, I wasn't sure what was going to happen when I started, but overall this data appears to be fairly normal. All right, to review those four things, we've got a graph that shows some amount of symmetry. It wasn't great, but it was all right. We have a mean and median very close to one another. Remember, if the data were skewed either way, the mean would get pulled quite a bit. We checked the 68, 95, 99.7 rule, at least one step of it, and we can check the rest later. And our normal probability plot formed a pretty straight line. That's about as straight as a line as you're going to see on the normal probability plot. We're not going to look behind the scenes at that one too much because that's just going to be time we don't need to spend. You make it, you see if it's straight, and that's that. All right. So I'm going to end this one with a stats joke. There's not too many good stats jokes out there, but this is one. 3 statisticians go duck hunting. The first one shoots, bang, misses it high. The second one shoots, bang, too low. The third one says, "We got him!"